All right, thanks everybody for joining us today, taking your lunch time to learn a little bit more. We're going to show a couple of case studies today. We're back in the office this week, so that's cool. The lighting's a little better. Thank you for joining us on the previous calls. Today we're going to talk a little bit about our customers' electrification path. Everything are things that customers and contractors should consider along the way. We're going to have an EMH customer interview today, and then we'll close with the class survey, closing and wrap up. Please take time to fill out that class survey. It's really great at the end to be able to look at that and see where we can do better. This is number 5 in our 6-part series, Heat Pumps Done Right, a case study. We have a special guest today, as Javier mentioned. He's sharing a case study as well. And we're going to share a case study from a 1901 home in Oakland, California, a nice duplex transition home, and a really interesting project there. Join us in 2 weeks for the why and how of home performance and electrification, when we're going to talk about why home performance is important when you're installing a heat pump. As always, the hashtag Electrify Efficiently, our areas of focus are building electrification, single family residential for us, HVAC and water heating heat pumps, overcoming barriers with our customers, sharing approaches that optimize for comfort, efficiency, resilience, and low operational cost. And everybody's going to benefit from this, especially if you guys are this one, just about everybody. You're going to get some good stuff out of today's presentation. As always, we start with our metaphor of helping our customers with electrification at their own pace. And we couldn't find a better video to just emphasize at your own pace. So today we're going to talk about the path. The order of operations on any electrification project should be strategic and contain these 8, at minimum 8 topics. We want to make sure that we're looking closely and fixing any kind of safety issues during our process. We do a complete electrical panel assessment. We design and recommend future wire for appliances, and we look into pre-wiring those, so our customers, when the water heater goes out or the gas stove dies, they're ready to plug in a new electric one. Addressing your ductwork is very important on these. There's an important message in here about that. Improving your building envelope is super important when we're using a heat pump, because remember, heat pumps heat with a lower BTU rating. Those units of heat are not delivered in the same rate as a gas furnace. So we just need to be putting that into a good envelope. We recommend always, if your ductwork is in the attic space, you need to bury that with insulation so you can put a little distance between you and that hot attic temperature. Always insist that your contractor perform an HVAC load calculation. This is not going to be a preset form where a lot of numbers go in and then magically out the other end turns out whatever size they think you need. You should do a manual J and manual D load calculation on these at minimum, so you can determine room by room airflows and also what size system you actually need. And then number 8, begin replacing the appliances in the pathway that makes the most sense for your particular project. Do that gas assessment inventory. Look at your existing gas bills. If you're not horrified by those by now, you have a high tolerance for pain. But the PG&E online portal makes it easy. Just go to pgne.com/home checkup, or you can go to our website, electrifymyhome.hea.com, to get a home intel report. Those are really good. They disaggregate your energy costs and tell you where you need to improve. Just all you do is fill out a form, and they send you a great report based on information that they can get from PG&E's website. Build a list of gas appliances in your house. The furnace, water heater, we don't want to forget any of these, the fireplace, the pool heater, the stove, the dryer. Make that list, figure out what you're going to need electrically moving forward, and make your plans based on that. We like to electrify houses with existing panels, and we do that by making good choices. Your electrification roadmap can take different directions, but it's all really going to boil down to the same 8 electrical conversions. Some houses may only have 1 or 2. If that case, you're going to get off pretty easy. But pay attention to these. We want to make sure that we do these things in the right order as well, as we talked about before. Like you don't want to insulate your attic if you've got ductwork up there, if you're planning on putting a heat pump in later. That should be something in case those ducts need to be replaced or modified. You don't want those covered up with insulation. And when you do insulate your attic, you want to make sure that the ducts are below the insulation and not above it. Chart a course and plan your budget. Here we have the timeline we shared with you before. This is how a lot of people are doing this. But you can start with something just as easy as changing out all that lighting in the house to LEDs. You can get yourself a nice new induction cooktop, or you can just go to Amazon and pick up a nice little 2-burner or even single burner induction cooktop to get you away from the gas in the short term. Then looking at that heat pump, make sure you get a contractor that's going to stick with those 8 guidance points. Then the heat pump water heater. Some of you might already have the solar PV before that. Then you may need a new electrical panel, want to get that battery storage, and finally there's that opportunity for the heat pump clothes dryer. Those have come a long way. They've gotten a lot less expensive too, just pricing out a couple of those yesterday. Find an electrification partner. When you call around looking for a contractor for this, make sure you talk to contractors and ask them some pointed questions to find out if they're really into electrification or they just want to sell you a heat pump. Because if they just want to sell you a heat pump, chances are they're not going to take all these things into consideration. So it's really important that gets done. So you want somebody that's going to be experienced at assessing your panel capacity. Familiarity with replacing options for all gas loads. I would ask questions if they're familiar with induction ranges. A great question for one of them would be, what do I do about my gas dryer? A company that understands the complexities of running the appliance circuits or can put you in touch with an electrician that can do that for you, because as we'll show you in this case study, it's not always easy to do that. Find a contractor that is willing to do a manual J calculation with room by room airflow. For a heat pump to work optimally, we need to have the duct system designed in such a way that the airflow that is necessary for the capacity of each room is being delivered, because heat pumps need to run a lot longer, and longer run times can help mix the air and make the house more comfortable, but it can also exacerbate comfort problems if we're getting too much or not enough air into a room. Understand maximizing efficiency through downsizing, thermal envelope, and specification of correct equipment. We typically downsize our systems pretty radically. We do the envelope work, which theoretically reduces the capacity of the house, basically makes your house smaller so we can address it with a smaller system, and make sure that they understand the different options that are available with heat pumps, and they just don't show you one pathway. A lot of contractors are resting on traditional single stage heat pumps with backup heat and an air handler that could take up to 6 spaces and up to 70 amps of capacity on your panel. It's very important that they can show you an option that just takes 2 breaker spaces and can do a better job. Experience, they should have experience installing multiple types of heat pump technology. Inverter technology is kind of your friend when you're upgrading to a heat pump. Make sure your company is familiar with that and they can explain it to you in a way that you can understand. They should have access to multiple brands. No one brand has all the options covered. So it's important to have a contractor that has access so that they can create the proper solution for your particular home, because a lot of brands don't have the selection necessary to do unique projects or things that are outside the norm. And then always, always, always make sure that they are planning on pulling a permit. This is a question that you should ask every contractor, because we talk to customers all the time that say, oh, we got another bid. There's nothing about permit on here, or they said the permit wasn't included. And just deal with a contractor that is going to get the permits for you, make arrangements to get the permits, and have the jobs inspected. You're just protecting yourself, your property, and your family. Because we know poor workmanship is expensive. It is really expensive to get a system installed wrong. You think a good HVAC company is expensive, try getting a bad one and then having to do it all over again. Not everybody shares the same idea of quality. This picture here should give you a little chuckle. But you know, you're asking for a 5-zone system that can be completely different in 2 different salespersons' mind. So here we're going to move on to our case study today. This is a beautiful home in Oakland, California, built in 1901. Just a gorgeous classic home. These homeowners have lived in this house for just over 3 years. This customer, they have 2 families living in this home. Upstairs is a family with the mom and 2 children, and downstairs is a married couple with 1 child. And it's an absolutely gorgeous remodel that turns out was not comfortable, and we'll get to that in a minute. But beautiful opportunity to work with this wonderful, wonderful family. We collaborated with Redwood Energy on this project. They did the project management on it and kind of oversaw the project, help just kind of approve our design, which was no problem because our designs are always awesome. It's over in Oakland, 2,616 square feet total. Their goal was to reduce energy cost, upgrade for safety, and fix the comfort issues. They were not happy with how uncomfortable their home was. And you'll notice by the pictures we're going to share that we took out some pretty modern equipment that didn't do the job because it wasn't well thought out when it was installed. And then their end goal was to be net zero. This customer is putting on their solar, should be installed in the next 3 weeks, and they will be 100% zero energy cost with the solar system that they're installing and the electric equipment that we installed. First, you got to do that panel assessment. So in this particular house, we were blessed. They had a nice 200 amp panel. As you can see here on the left, there was quite a bit of room in this panel. So we had no problem. Our equipment actually ended up being just to the right of this panel. So it was an easy hookup, lots of space inside, easy for us to do. The only issue came when they sized the solar system, is that when they put the electrical in originally, they did this 200 amp system, and then they put 2 100 amp sub panels. So one of these sub panels existed in both spaces. But if you take a quick look at this 100 amp sub panel, it only has one 240 volt load, and that's the dryer in each apartment. And all the others are just plug and light load. So really this sub panel, these were also installed in such a way that you can't get any wiring into these. They were on inside walls of the house. So all this 100 amp sub panel was just kind of really a waste when it was installed. It was completely unnecessary, but it made it good for us because we had plenty of capacity left in the main panel. This was their furnace for the downstairs system before, and you can kind of see how lazy the duct is here. That was part of what was going on with it. It had too small of a return. All the ductwork was not connected properly in this closet. This one presented a bit of a problem because the ductwork all snuck between the floor and the ceiling of the two condos, and so we weren't able to actually replace that ductwork. But this whole remodel was done just 4 years prior, so we knew that the ductwork was in good condition. And as a matter of fact, this tested out at 3 to 4% leakage, I believe, when we were all done. some of the ductwork came right off the plenum and served a room here and here. And the other thing that we did is we increased the size of the return. It was a 12 by 24 before, and we put a 14 by 30 in. I believe it was a 14 by 30. I think there's a picture of it. Anyway, and then we used the proper type of grill and increased the return air duct size to an 18-inch duct from a 14-inch duct. And we put in a system that was quite a bit smaller than this. So this is the upstairs system, and I got a little corner of the furnace here. I couldn't find the picture of the whole furnace. This ductwork was not in that bad of condition. The vapor barriers were fine. We did take all the insulation off the Ys and reseal this entire ductwork, but when we did our load calc, the ducts were fine for what we needed to do. So in this particular application, we were able to save them. Obviously, one of the things we did was to cut the straps on the ductwork, lay it down on the insulation. We did peel back some of the fiberglass insulation bats and seal the surface of the attic over the door, over the walls and doors, and we're able to reutilize this, which saved the customer some money that they then put into the water heating system. Actually, their domestic hot water system, the first couple of years they lived there, they had one 50-gallon gas tank that they were sharing in this property. And I'm not sure if it's in the video, but she talked about hearing the upstairs fill up the bathtub and knowing she wasn't going to be able to take a shower till the next day. So they moved over to these gas tankless units, and these gas tankless units were loud and kind of obnoxious, and a little bit they had what we call cold water sandwiching problems. And they did do the trick where they got continuous hot water, but it did exacerbate the issue of waiting for the hot water. Because as we know, with tankless water heaters, you have to wait for the system to come on and come up to temperature while the water is flowing through it in order to get it up to temperature. So all that water comes out as an initial blast of cold. This is the amazing water system that we put in. We were able to still maintain most of her closet space in there, which was wonderful. This is a Sanco 2, a CO2-based refrigerant heat pump water heating system. This particular one is running two 83-gallon tanks. The customer's message to me is, I don't want to wait for hot water, and I don't ever not want to have hot water. And I said, this is the way you need to do that with electric. So you notice here, both of these systems have mixing valves. The tanks are being held at 150 degrees, and then we have the water mixed down to 120. So I can't think of a situation where they would use a boosted 150 tank of 80 plus gallons of hot water in one of these places. So she will tell you in the video, it literally changed her life. But keep in mind, there was a lot of complicated plumbing in this system, and as you can see, we knocked it out of the park on that. The post-install, we installed two forced air mini split based heat pump systems. These are 24,000 BTU. Which enabled us to keep the ductwork in the attic. You can see the line cap work here, where we had to actually run the line set up and across and through the garage and through the kids' room and then into this furnace closet, which was on the other side of the building. Now, this building didn't have any kind of crawl space or accessibility, so we were able to get everything over there that we needed just by taking a kind of an unusual path, but it turned out very nice. And for those of you that have to run these lines down the side of your house, you can see how much these line covers actually look like downspouts. So they can kind of fit right in, and they can be painted. They're going to paint them up. In the downstairs seat, we changed the assembly of this unit, as the old one had the return air duct attached directly to the side of the furnace. We built a mixing box at the bottom that was able to establish the location for our MERV 13 filtration system. It increased 18-inch duct and redid the supply ducts and everything on the top. So she is getting extremely good airflow in this particular house. This unit was easy to install as well. It was in a horizontal position, so it kind of took the place of the existing furnace. And the capacity was well within range of us being able to keep her duct system. If we would have downsized this system one more half ton, we would have had to change the ductwork. So they were willing to take that. Since these systems have an operational capacity of up to 29,000 BTUs of heating all the way down to 5,300, there's plenty of downside modulation to keep the house comfortable. Big deal, using the right registers. If you have these in your house, they're bad. These are bad. These are not good registers for mixing the air in the house, but a lot of times they were used, especially when a system was oversized, because they kind of shoot the air in a couple different directions. And when your system has very short cycles because it's oversized, it helps a little bit in getting air in a few directions. But when we have a system that we want to leave on and keep running, and it's going to modulate down to that lowest rate, we really want to have the proper type of register. These curved blade registers in the ceiling are they're going to provide one single jet of air across the ceiling, which during the longer cycles of this system are going to mix the air through entrainment in the room. So registers are very important, including return air grills. This is a very, very low loss grill. You can tell by looking at it that there's not much restriction here. There's not much, there's no bars or grills or stamped metal. So these are extremely quiet and also move a lot of air through them. The R50 in the attic space, you notice it's a little lumpy. There's actually ductwork under here, and that's why it's slightly lumpy, but a really good application of R50 insulation. When you have R50 in your attic, it creates a 50-degree defense between the attic temperature and the house. So if it's 125 degrees up here and it's 75 in the house, you're not moving any energy through this R50 insulation. So it completely separates these two thermal boundaries and pressure boundaries so that we can not worry about how hot or cold the attic is anymore, because we have a 50-degree separation between that and the living space. We pre-wired the house for induction ranges. This one here is the upstairs model. We had to actually go up into the attic over. We had to come down through here, behind here, inside the wall, and put the plug behind here. That is not an easy electrical run. This was an expensive electrical run. It took a day and a half to put this one wire in. This one also, these ranges were not on the outside walls. So we had to, on this one, we came through an outside wall over here, had to come back through the cabinets, duck into the wall, and put the plug in the back. So these were very, very tricky and a little bit expensive. So this is why you want to plot all this stuff out and understand the right order of things. Here's some of our crew out there getting it done. This is Mason on the left and Dominic in the back and Daniel here out doing their jobs, making stuff happen. Our crew out in the yard are actually fabricating the sheet metal plenums and building everything from scratch, so it's exactly what's needed for the project. These are great crew guys. These guys love electrifying houses. This is our favorite part of all these jobs. Capped gas lines. I tell people all the time, didn't install a furnace yesterday, not going to put one in tomorrow. The only thing we do with gas is cap the lines. So it's really important that this all gets done right. And this customer is saying goodbye to her entire gas system. So let's share the video, the interview with this customer, and you can get a feel for her.
Hello, my name is Jay. I am with Electrify My Home. We have Mary here with us, who was one of our customers, and we decided to go ahead and ask her a couple questions and get her feedback on how she's enjoying her new equipment that we installed. So Mary, why did you decide to go all electric?
We really started the project with we wanted to go solar. We didn't even understand what going all electric meant. The education of the different products to become electric was all learning. We just felt like we were in a time in California where prices are skyrocketing. We didn't know what the future of that looked like. And there were some safety concerns working with PG&E, and we just thought it was better for the economy and the environment.
Tell us about what electric appliances you've had installed.
So we had this miraculous thing called a heat pump. I didn't know how heat pumps worked, so we have several fans on the side of the house, and they put piping through the house with a liquid that rolls through it.
Yeah.
And that's the system. So we got a HVAC system, so we're a 2-unit building. So it was a unique project that you guys worked on because everything was about each unit. So we have 2 of everything.
Yeah.
So we have something for the upstairs and something for the downstairs. So HVAC unit, heat pumps, and the water heaters.
Nice.
Maybe
Awesome.
maybe even a couple more things I don't know about.
Can you tell us about how you stage the replacement of your gas appliances?
Yeah. We also had a consultant who partnered with us and Electrify My Home and ourselves to help give us the education we needed. We basically just went for it. We had all appliances installed all at the same time, except for the gas stoves, which are happening as we speak. So the gas will be completely shut off soon.
Awesome.
Yeah.
So you mentioned your water tanks. You have a unique water heating setup installed with the Senko system. How is the system performing?
It's a dream come true, and I know that sounds cliche, but every time we would talk to our friends, oh no, I can't believe you're going to do that. You're not going to get enough hot water. It's going to be noisy. You're going to have this problem, that problem. And none of it was true, because we don't just have one hot water heater. We have 2 83-gallon hot water heaters in a closet, which is right near my office, and I don't hear anything during the day. And it's smooth. In the past, we would run out of water with 1 bath. And now we can take 2 showers and a bath, and it's the perfect temperature.
Awesome.
It's smooth. It's almost like I want to jump up and down and tell all my friends how wrong they were.
Do you feel like your new systems are quiet?
Yeah. It's not just the hot water and the pumps. It's also the HVAC system. They also have pumps and fans.
Yeah.
And that is right at our front door, in a closet next to our front door, and we don't hear that either. And I was also concerned about the vents. As the vents were coming into the house, all the vents were redone inside to create this optimal heating environment, which shockingly worked. I thought this is a strange thing to be fixing. And when it comes into the house, I can hear it. The first day I was like, oh my God, the heater's on. But after like literally 2 days, I don't even notice it anymore. It's just this quiet circulating system. I don't know how to explain it.
How would you describe your comfort of level in the house?
Well, my unit is on the bottom. We were always a little subterranean, and I hadn't even realized it. We just didn't turn the heat on. So it would get really cold, and really cold in our child's room, who's got some health issues. And so we're always trying to navigate, how do we heat a room? How do we be warm at 5 o'clock at night when we come home from work? And it was just cumbersome. I feel like we were, this is sad to say, but almost like living in squalor. We were like living outdoors, but indoors, and trying to save costs on heat. And it was just the first night, I hadn't slept that well in like 3 years of living here.
Wow.
Because it was calm, cool. When you're temperate, when you're the same temperature, it just, your whole life changes. It feels different.
Have your energy bills been acceptable?
Right now we're getting ready to let PG&E know we made a change, because right now they don't even know we went electric. And so there's some special rates apparently when you have electric systems. So we're gonna be doing that. But we never had the heat on before. So things went up a little bit, but not noticeably. As soon as the solar's on, that's gonna bring that back down to a neutral cost. So we are eagerly ready to finish the rest of the project.
Sounds good.
Yeah.
Were there any bumps in the road during your journey?
No, I mean, it's always a little dramatic to have, 8 or 9 guys bringing in tons of equipment and sheet metal, but everything was custom done. So they worked in the driveway. Every night was cleaned up. Everything was smooth. And the crew was so friendly. If I had a concern or a question, they addressed it immediately. I've had a lot of contractors I've worked with in my lifetime. Not a team has ever been more professional than the Electrify My Home team.
Thank you.
Yeah, you're
That means a
welcome.
lot. How does it feel to be gas-free?
Gas free. Well, I miss my gas grill, but that's okay. We're gonna fix that. I don't need a gas grill. We'll have another kind of grill. In terms of safety, you know, we had a big PG&E project replacing the main line, which I learned later should have been done 4 years ago. So we were living with like an explosive tool on the side of the house, and that just made me really nervous. The prices are literally tripling, and so we don't have to deal with that. It's great.
Nice, good. So you've already touched on this a little bit, but tell us about your experience with our installers.
The guys were great, and I say all guys because they were all guys. They were bringing massive amount of equipment in. They were doing a lot of custom work, and they did it like, I think the schedule was 7 days, all day, every day, and they got it done in 5.
Yeah.
We were shocked they were done early. It was just literally the most professional team of contractors I've ever met.
Nice. And is there anything that stood out about your experience with the Electrify My Home?
I would say it was the bidding process. We've had so many teams of solar, electric equipment, this guy, that guy. But when Larry came out, he knew immediately. He understood the 2 units, he understood the property. He was very quickly able to assess the situation, and then he remembered everything. He was like, oh, I know what this project is, this is what we're gonna do, this is the best style of equipment. And he was so confident. And I think he was confident because he's just done it a million times.
Yeah.
So that experience really made a difference.
Do you feel like we respected your property?
Definitely. I think especially the neighborhood we're in, it was really important that equipment is put away every night. And I know when you're coming back the next day and you're long days and exhausted, that's like the last thing people want to do. But every night, we put things in the garage, we tucked it away, we swept up. We've got a small dog. He likes to eat all the things. And so we made sure there were no nails and screws and things. And they were very much attention to detail. And that just made it great at night when everyone's gone. We're like, oh, wow, it's not so disruptive. So it was important.
Great. And is there anything else you'd like to tell us?
We're just so excited to finish getting the solar put on here in the next couple weeks. The economics is going to completely change our lifestyle. The amount of money that we're saving monthly is like $500 to $700. So we'll be saving for our college education for our child, and it's just kind of shocking how an adjustment like this messes with your budget.
Yeah. Well, Mary, thanks for having us and letting us come out to your property. It's very beautiful.
Thanks.
Thank you for your time.
Thanks for changing our life.
Yeah.
All right. Well, that was pretty cool. So let's wrap that up. The key takeaways: thanks for changing our life. Her journey, they just went for it. The domestic hot water system was a dream come true. She literally says she doesn't have to listen for the people upstairs taking a bath anymore. The HVAC system is incredibly quiet. All the vents were redone, which shockingly worked. It wasn't shocking to me. The first night, they hadn't slept in years. This is a big deal for some people when they're not running their systems because their houses are so uncomfortable. Getting the proper sized heat pump and properly designed heat pump installed is a dramatic life change for sure. That comfort is just, people don't understand what comfort is because they've never lived with it, especially in California, because we've notoriously put too big of equipment in forever. And comfort is not how fast your house heats up, it's how warm your house stays. And the operational cost. Her bills did go up a bit. She's waiting to get the solar coming in, but obviously she has 3 new electric systems. They've completely eliminated their gas bill at this point, except for their ranges. I believe their electric ranges are going in today. But all of these changes are, people are thinking of electrification as like this thing. It's taking away my choice and I can't have gas anymore and doggone you, whatever. But realistically, technology is so far ahead in heat pump technology than gas technology that it's going to completely change our life for the better if you make sure that you have a contractor that is doing it properly. So remember those 8 points that we talked about earlier. Make sure they're going to do a load calculation. Make sure that they're going to change the registers. Make sure they understand what they're doing. And then they're very just the mindset of knowing you're safe and don't have gas in the house anymore is something people don't think about till the gas is gone. So with that, we're going to take it over to Tom Danielson. Thank you guys for your attention once again. And I believe Javier is going to switch that over.
All right, can you guys see my screen or no?
Yep, just needs to be full sized.
Okay, let me work on that. Pardon me, let's see. Something here. It's not full size now?
Yeah, it is.
All right, hello everyone, my name's Tom Danielson. I'm a contractor up here in California, Angels Camp, so Calaveras County, foothills. And I want to touch on something what Larry was saying a little bit. I guess you can hear me, right, Larry?
Yep.
Anyway, hello? You can hear
Yep.
me?
Yes,
okay.
sir.
I want to touch on something what Larry was saying. When you size the equipment right, and this is something that we see a lot in our climate zone up here in Angels Camp, is we see that we are putting such smaller air conditioners, and we're saving so much money in the air conditioning side. As far as the electricity, it's paying for the heating cycle. So when we electrify a home up here, we're seeing no change in energy bills because of the savings of the air conditioning, and that's even giving them, we are on propane, that's giving the propane as a bonus. So it's pretty dramatic when you're sizing the equipment correctly. Now I just got to figure out how to use my stuff here. So anyway, I'm Tom Danielson. We have a project that I was involved in. I sit on the board for Habitat for Humanity, and we have this project of 107 homes that we're building up here in Angels Camp, and we were building one home, and I asked my board, I said, this would be amazing if we could do an all-electric home and do it as a pilot home and turn these homes all electric. And with much resistance and explaining and meetings and approval, they let me have control over the project. And I'm going to talk a little bit about what we did, and we have a year's worth of data on this, and we have some really cool run times and data points. Let's see if I can here we go. All right, sorry about this. So this is our house. This is in Copperopolis, California. It's 1,250 square foot house. We only have 2.5 kilowatts of solar, and actually this house was on such a low budget that we didn't even have room for solar. And we had a solar company drive by and actually donate the solar for us. So this solar was for free. So again, it's just a little 1,250 square foot house, brand new construction. So my scope of work that I was able to put in was trying to do this with no additional dollars, because money was a big factor. We have no money basically to build these homes. So I asked for a few things from the contractor that was framing it. I asked him to do a little advanced framing, what you're going to see a picture of in a minute. Just leave the outside corners open. We were 2x6 framed. So I asked them to put like a little smaller dimensional wood over the header, and you'll see pictures of that in a minute. So it's actually 2 inches shy of the headers. So we have 2 inches of void space. The raised tilt roof truss was already in the plans, which gives us a little more insulation in the corners of the peaks of the roof, right in these areas here, if you can see my pointer. We did a lot of air sealing, just typical air sealing, which I'll show you a few pictures of later. And these bathtub holes and these raised foundations, there's 2 bathtubs in this house. Normally they cut out a big 12x12 hole underneath it, and those are never ever dealt with, and they're just like big communication holes from the crawl space into the house. So we dealt with that. We like the Owens Corning L77. It's a bibs. It's a blown-in blanket setup. It really works well for encapsulating around pipes and getting a really well-performing wall. We used the same material up in the attic, which was, we were able only to get it up to R40. We could have done a little bit more. Some areas might have more. We were only able to bury about half our duct system. Our duct system had 5% duct leakage, so I would consider that, in my world, very mediocre work. Our floor insulation was a nemesis for us. We'll show pictures of that. We had to put R38 in for this TJI floor truss assembly, which is really popular now and really hard to insulate. We used an entry-level window called Amsco, but what's cool about using Amsco vinyl windows, we can use this really cool company called Cardinal. Cardinal makes the glass for almost all the glass that's provided in probably United States. They do Anderson, Milgard, they provide glazing for all of them. So we're able to get this really cool Cardinal 366 high reflective glazing, which is very low cost. I mean, it was like $300-400 additional extra cost just to put this really cool reflective glazing in. And then we go to where my expertise lies, and we did a fully designed and installed ducted inverter heat pump system. And I'm going to talk a little bit about the 50-gallon heat pump water heater. So this house is all electric, 100%. So up here in the left-hand corner, this is just how he framed the corners. Very easy for a carpenter that has any experience to do. So we can just get a little bit more of insulation here. This is the raised heel. So these corners are raised up. Usually it points out right here, so we have a little bit of space so we can put more insulation in these areas here. These little areas were left so we could put in ventilation into the attic. And this is our bib setup to the right. We have the whole setup for Owens Corning, and we net all of this insulation. We net all of the exterior walls, and we have this machine, and it shows us density, and the density shows us R value. So when we're filling up these walls, we know exactly what R value we're giving our customer. And we use this really cool material at the bottom. This is called Great Stuff. It's sill gaskets. So this is done when the job's done. I just had to show this. It's very fast, and it goes in interior and exterior walls, all the top plates right up here. This would be an exterior wall, but we put it on every single top plate. So that makes it so this wall cavity is airtight and no air can get behind the sheetrock or the exterior walls and push up into the attic. And it does another thing for the exterior walls. It really improves slowing down the convection loop in the walls. So our fiberglass wall insulation can have absolutely more performance. So here's a little example of how we fill up the walls. So here is, so we had a little bit of a void on the top. I said we had the 4x on top. So we put 2 inches of this polyiso. People call it tech foam. It has about R6.2 per inch. So we got a little extra R12 value over the headers, and the carpenter or the contractor on the no-load walls left us space. So we got real good insulation on the top of the windows. So this was a very inexpensive upgrade for us to do. You just have to understand what you're doing and talk to people to do it for you. So I thought this was a real effective, inexpensive way to add some insulation to the home. So this is my nemesis. Not a lot of insulation contractors know this nemesis, but when insulation doesn't touch the effective area, this is a floor joist, this is a TJI truss. They want to put a steel rod under here called a lightning rod, and they want to just put this insulation in, and it looks fantastic when it's done. It looks like you have the most insulated floor you've ever seen. But in reality, when you pull it down, there's 3-4 inches of void up in here, and it becomes ineffective insulation. And here's a great picture of coming down. So this is really hard to deal with as far as bringing it together. We've done a lot of things to deal with it. We have nothing that's perfected yet. This particular job here, we ended up using a substantial amount of money buying 2x6 and pushing it up so that the insulation will touch the floor. And all different TJIS trusses are different widths according to the spans. So the lower stuff is easier to deal with than the taller stuff. So this is how we dealt with this stuff. Sometimes we're doubling the insulation. This is why we put an R38 in the floor on the prior job, just so we could fill up the void and push the insulation to touch it. So it gives them a really amazing floor system, but unintentionally. It's only before us to deal with the problem we have with these trusses. So this house is 1,250 square foot. So a typical home, air leakage, if you're going to run a blower door on a home, a typical home like a regular home, it could be anywhere from 800 to 2,500 CFM 50. I mean, that's just a big number. 800, 900, 1,000 in the real world would be acceptable. So with the little bit of effort that we did, we were able to get our leakage down to 189. So this was low effort for our man, but it would be high effort for my man, but it would be high effort for someone just starting. So we got these real amazing air leakage numbers unintentionally. I think our target for our HERS or for our permit was like 350. And our duct leakage, we just made minimum duct leakage on this house, which was 14. If this was set to the outside, it's a little bit differently. It would actually read 0 if you were just testing the ductwork. So correctly installed HVAC is impaired. I can't tell you how much this means to the performance of your home. You can have the best insulated house and you can have a horribly oversized system. Anything that runs as with a compressor, a refrigerator, it could be a gas furnace, it could be a gas water heater, it could be an air conditioner. Everything takes 10 to 15 minutes to get to its full running cycle of efficiency. So if your furnace is turning off and on and off and on and off and on, it never reaches its state of efficiency. So long run cycles are imperative, especially for a heat pump and especially for air conditioning. Air conditioners that go on and off and on and off just blow up efficiency. And we see this, as I said earlier, we see this in our climate zone when we put correctly sized equipment that has long running cycles. We see huge amount of savings, hundreds and hundreds of dollars in savings. So on this particular house, we did a meticulous load calculation, right-sized equipment, short duct design, right-sized ducts, right-sized registers, as Larry pointed out in his, commissioning the system, air balancing. So actually putting it all in, and then let's bring it back to our design and let's make it work how it is on our paper, on our design. And all our HVAC design systems are running 24 hours a day with absolutely no setback, 365 days a year. That's in the summertime and the wintertime. And we have some data on this. So this is our I use RightSuite. I think Larry uses RightSuite. This is my design. It does the full load calc, as you can see here. This is a 1,250 square foot house. Our heating load for our design was at 11,240, and our cooling load miraculously was at under 7,000 BTUs. And that's like any contractor that would come and look at this would say, I'm not putting this in. This is crazy. So not only does it do the whole house, it does room to room loads. So every single load in the room is figured out. It does our pipe sizing. So every single pipe size is figured out. So we have this perfect airflow running through these registers. We want to see like 400 to 600 CFM per minute running through these registers. It has to run this speed. If it runs slower, we have this conductive loss. So we have this real big gigantic ductwork. We're getting really good airflow, but we have these big ductwork and it's just pulling the heat from the attic. This, as I didn't say, this is in the attic. So you have all of this going against you. So if you can make this whole system right and just make these runs short, use the right size ductwork, there's a huge amount of savings here. So we also use straight boots, which is here on the left. So we don't want any kind of friction. We have put a 90-degree elbow right on top of it. Anytime we're turning like around or doing a U-turn, we're using multiple 90s, smooth wall 90s, so this flexible ductwork doesn't kink. Then everything in between is this flexible ductwork on the right here. And then we use a lot of nickel deep mastic. You know, mastic, Pookie is our best friend. My man use lots and lots of this. It's becoming very expensive, but we still use a lot of it. So when I design a system, I want to do short return. So the return is right here. I don't think this return is 6 feet away. That's our biggest duck. That's the biggest nemesis in this project. So we want to get that really close. So everything is figured out. We use these Shoemaker's FCCB10 registers. We design these registers specific size for the amount of airflows. Like 11 CFM, we use this little 4x4. So this probably 39 CFM, we'll use like a 4x6. So everything has to have this great throw. So we have this entrainment that Larry was talking about earlier. And I wanted to touch on this also. Entrainment does not work if your airflow, let me see if I can explain this correctly. The supply or the return. So the return, the difference in temperature of the return and the supply has to be really less than 25 degrees. So if you have a gas furnace and you have 130-degree air coming out of it, and your air is 75 degrees coming in, your delta T is going to be 80, I think, 50. Anyway, it's above 25. So what's going to happen is that air is just going to want to sit in the ceiling. There's nothing you can do. There is no entrainment. It just wants to sit. This is a hot air balloon effect. So heat pumps are awesome because generally, if the house isn't cold and it's mixing the house, the difference in temperature is always less than 25 degrees. It's only doing what it can do, especially on these inverter systems. It's only doing what it can do to keep the house warm. And I have some data on that. So here's the equipment we chose to use. We use this 12,000 BTU Fujitsu slim duct. It's a ducted system. These systems are very sensitive to pressure. They can't push air very well, so the ductwork has to be pretty much perfect. And something I'd like to touch on, especially at Fujitsu. I use a lot of Fujitsu, so and I like their products. They have a lot of different variations of, we can fix a lot of projects with them. But here, right in here, it shows you your cooling. My cooling goes from 3,100 to 13,600, and my heating goes from 3,100 to 19,400 BTUs. So here are my loads. So I'm like way oversized for my cooling on a 1-ton system for this 1,250 square foot house, and I'm right in there for my heating. So I felt real comfortable with my pre-design using this piece of equipment. And my Title 24 person said, "You're crazy. This is too small. We never see this small of equipment." They said, "It's your job. You're responsible for it." I says, "Yes, you're correct." So we ended up doing this. And here's a picture of the actual unit up in the attic. It's very important on this specific type of equipment that you leave the underneath, a little bit of height. We have a lot of ductwork that's in the air, but that's it's just the way we have to work things with this equipment. You have things that are good and things that are bad. The blower assembly is at the bottom, so you have to have access to repair anything if there's any service required on it. So we hang these things up, and then you can see half of it's buried, and this is our attic, and that's where I'm saying only about 50% of my ductwork was buried on this job. It's not exactly textbook, but it's what we had with what we had to work with. So here's a typical hot day for this piece of equipment. So you can see this red line right here. That is our temperature. So this red line is our temperature line. And these lines across in this green, that's our BTUs, or watts, I should say. So this particular piece of equipment, it's in July, so it's one of our hot days. I don't know if it's in July. It's a hot day. Anyway, it's running. It's here right around 75 degrees, and it's just keeping, it's as much as the transfer of energy is moving out or moving in, it's just keeping up with it. It's running on very low stage. So this system was designed for 12,000 BTUs. You can see our cooling load is really low. It's probably on very low stages. It's on its first or second low stage because it's a variable stage piece of equipment. The compressor can go up, it can go down, and it's just finding its sweet spot. And it just has these long run times, and it's just loving life right here, and it's working at its best efficiency. So it's running from 600 to 800 watts that day. It was probably over 100 degrees that day. Another typical summer day, I just wanted to show the long run times. So we're at like 70 degrees and it gets down to 60 degrees here. Then it shuts off. This in the summertime, it always has a little fan running. It wants to run the fan inside. So you have this little bit of phantom power going on here, but it just turns on and off when it needs it here. And then, you know, it gets hot and then it just runs. And then I guess somebody turned down their thermostat and it just runs and runs and runs. It just wants to run long periods of time at very low amounts of energy. Now here's our cold days. Our cold days are, okay, so we're looking at here, 45 degrees and it goes down to, we're down into 30 degrees here. So uses much less power to heat the house. Even though our heating load was more, if you can remember on our heating load, it just runs and it just runs. Here's 300 watts, 400 watts. I don't know what happened here. Maybe this goes into defrost here. It's cold at night. And then nothing, you know, gets warm in the daytime and it just shuts down and then starts running again. So really long, sweet run times, really low amounts of power. So this is why it's very important to run the correct size equipment. When you have data like this, it shows you that, you know, it loves to run and it loves to run at low speed and the comfort is unbelievable in the house. So here's another typical cool day here in December. This was last December. So this piece of equipment is just running, you know, it's 35 degrees out. It's not even on high stage. This is probably first or second stage. I don't know how many stages it has, probably maybe 10 or 12. And then all of a sudden, the sun comes out, doesn't need any heat. You know, here's 7, 8 o'clock in the afternoon, comes on again. Just these long run cycles, just these beautiful, long, efficient run cycles, very low consumption of watts. So I just wanted to show this is part of this program. I didn't talk about this equipment that we installed on here. I missed that or slided that. We have a company that sells this equipment. It's called SiteSage, and it has a CT circuit on every circuit, so we can see what all the circuits that are being used in the house and the whole consumption of the house, which I'm going to show you data on in a minute. And I'm just zoning in on the heating of this Fujitsu unit. And it's just showing you the usage. It's predicted usage in, this looks like it's January of this year. This predicted usage in January, last month, you know, it used 162 watts. That was known data. It's predicted as 106 watts. This is 106 watts of power in January, or kilowatts, I should say, of power. So 106 kilowatts at 13 or 14 cents a kilowatt is not a lot of money. So here's an annual usage of specifically the slim duct. And this is just showing you monthly, I guess, data of heat right here and cooling. And this is July and August. These are our worst nemesises here for cooling the house. And it's just showing you that we used, you know, 275 kilowatt hours of, this looks like in July. August was really hot up here, so it's 300 kilowatts. So not a lot of usage, but, you know, we were seeing January that we saw earlier, and, you know, very low consumption of usage as far as the heating cycle. So these heat pumps are extremely, extremely efficient for heating, and they really work well for cooling. So this entrainment now, we were talking about entrainment earlier. So being that we can get this low delta T, which we're trying to keep the supply temperature and the return temperature below 25 degrees delta T, so the differential temperature, we get this really good mixing in this entrainment. So here's a picture of paper. You can't measure air, so you have to measure the paper. So we put this paper, you know, in the bottom of the house, in the middle of the house, and then this at the ceiling. And we're looking at this differential in temperature. So we have like 2 degrees differential in temperature. So this house is extremely comfortable from floor to ceiling within 2 degrees. And sometimes we can get it less than this. So another really positive thing with this heat pump, and especially these inverter heat pumps, because they run on low power and low heat. All right, this is, Larry was mentioning that he was using the CO2 heat pumps, which I love. Unfortunately, on these heat pumps, they're pretty picky on where the air comes from, and they're awesome. I love them, but the CO2 would be like the cream of the crop. But this particular 50-gallon heat pump water heater, I had to vent into the attic. So these two pipes just go in the attic. So we're pulling air from the attic, which I thought was good, and it's legal to do. Whoops. And I have a little bit of data on that, and I'd like to talk about it. So there's different ways you could vent this. I'm learning, you know, this is a learning process, especially if you have data to back this up. So in the summertime, we get really, really good run times and really good low watt usage. It's extremely good. So in the summertime, this thing really kicks ass. It really works well, uses very low amounts of power. In the wintertime, not so much. So through many phone calls and many frustrated hours looking at this and trying to figure this out, that even in heat pump mode, they have different modes, these things. They have like this hybrid mode, they have this all electric mode, and they have this heat pump mode. And I have this thing in the all heat pump mode. So when the air gets cold, the strips just go on by themselves. It doesn't matter what mode you put it in. So it just blows up your power and blows up your efficiency. And I wouldn't have known this if I wasn't logging this. I wouldn't have known this. So I've talked to a few experts in the industry, and there's different ways of venting these things out. And I'm going to address that. So as far as efficiency goes, this heat pump hot water heater was not so good. Way better than an all electric water heater, way better than a gas hot water heater, but we have a lot of improvement we can do with that piece of equipment we have installed by just moving the air differently in the house. So here's our water heater consumption. It's not horrible. It's not horrible. You know, 200 kilowatts, you know, it's not horrible. Summertime, look, works really well in the summertime. Wintertime, not so much. But we can get, when I fix this, we can get numbers like this. So this house is going to perform much better when I fix this problem. This house has been occupied for like 1.5 years now, and we have data on it for like 1 year and 3 months. So we can't, in an all electric home, we can't predict behavior at all. So the person that that purchased this house, she has kids and grandkids, I'm sure, and they do a lot of laundry. So we see, I just thought this was interesting that we see she does consistently between, you know, 60 and 70 loads of laundry a month. So we can't predict how people want to work. And she, you know, she wants to watch her kids' laundry and everything, which is great. So our usage for the washing machine for the month is very minimal for what she uses. 11 kilowatts. You know, that's like $1.40, $1.50 to wash 60 loads of laundry. But where the problem is not really in the washing machine. You know, she's consistent, you know. So it costs her a couple dollars a month to wash all these clothes, which is really awesome. But we have this thing with the water heater and the hot water, and you know, and that's why we're seeing these higher usages in the hot water heater. So you kind of want to say, in this particular house, this house was basically built to code, and we followed the letter of the code by the law. And we had a HERS rater that beat us up. So, and we did a really good HVAC system. So we kind of want to see, what do you think, you know, which uses the most electricity? Is it the water heater? Is it the electric resistive dryer, being that she uses does a lot of laundry? Or is it our heating and cooling system, which usually is the nemesis of the home? So here's the answer. The water heater. The water heater was my biggest nemesis on this house, and it's been my nemesis until we fix it. But it's not a huge nemesis. It's using $159 a year. You know, it's nothing. So on this particular house with 2.5 kilowatts of power, our true up from was from July to July was $310 for last year. It's going to be a little bit more this year. It's probably going to be $500 this year because we had our winter and we couldn't produce as much power this year. But last year our true up was $310 with 2.5 kilowatts of solar. So, I mean, this is pretty amazing. This is a low-income house with a person that does not make a lot of money, that does not have means, that can now afford to live in our house and live comfortably every single day. So, you know, her dryer usage was these are our 3 top nemesises. It's the slim duct, the dryer, and you'd always want to say that usually the space heating is what is our nemesis, and it's not. It's our water heater now. But I think I can bring this number down when I fix the venting system. I have talked to some experts in the industry at one of our conferences, in which I gave this presentation, and we have some ideas, and then I'm going to have real data on this. So basically, you can see lights, everything we have, all of these appliances down here, they're all figured out already. You know, we have really good variety of dishwashers. You know, our refrigerators aren't so horrible. You know, the washing machine's not that horrible. You know, this is all pretty much noise. You know, the big offenders are right here. Living room plugs, I think her son comes and plays Nintendo or something. They watch a little bit of TV. So, you know, that's our 4th offender. That's not huge. And we have to say, I think this in the software is amortized pretty much after their solar. So this is not a real number. This is after the solar. It's after the production. So this is not a real number of what it costs. This is after the production of solar. It's kind of just mixed in there. So here's our production of our tiny little solar system, 2.5 kilowatt solar system. This solar system, by the way, was, I think, our donated, they said it was $8,500 to install this. It was very inexpensive. We didn't pay for it, but that's what they gave us. They gave us that number for their tax write-off. So very inexpensive solar system. So, and really good numbers. I guess it has real good exposure. And these numbers aren't so good this year because we had a lot of rain here, and we're going to see a lot lower. So, but as far as that year, we did really good. So, and we were very grateful for the people that donated this to us. So, we have 107 houses to do. I get this, I'm an air conditioning contractor, and I get this Indoor Comfort magazine, which I usually throw out. So my wife was reading this article, and so I brought this article to our business in our meeting, and we applied for this CECBG loan, some kind of state loan. We met with them. Every measure that I did, we maxed out on this sample home. So we maxed out $17,000 a house, which is going to give us more. It's going to pay for more solar panels than for what code requires, and it's going to pay for some of the upgrades we already do. So we're getting $17,000 a house. So we have a reservation for a grant for $1.8 million for these 107 homes, which really helps us for these homes. I mean, $2 million is a lot of money, especially for people that don't have money like Habitat. So I have to say that we ironically barely passed. So if you were to say that I built this house, or we put this house together and we had a HERS rater that was by the book, we worked hard to get the numbers down. But if you were like, anybody was to build this house, nobody would look at this stuff. That's just what happens. Nobody looks at this stuff, they pass it. But we had somebody looking at this stuff that understood the code, and this was just like normal Title 24 code. We barely passed it. He caught us in a few spots. We got it together. We got these amazing results. So when we did some final cost analysis on this, we found what we saved on the HVAC system because of using smaller equipment, using less ductwork. We were able to put some of that money into the higher cost of what it costs to insulate the home. It's much more expensive to put, you know, R38 in the floor, and it's much more expensive to put, you know, R24 in the walls, and it's just time consuming. It's much more expensive to do air sealing and put foam in like you're supposed to. It's just more labor. That's why this doesn't get done a lot. So so we think with this training, we're going to do this as hired contractors. So we feel that all of this stuff is attainable. All what we did is very simple. It's very easy to do. We just have to train our people that are going to be installing this how we want it done, and then actually do testing to show what it's going to be. So we're hopeful that this can be a scalable project for these 107 homes. And the more and more I do this, we see that heating and cooling is not really a variable. I can see it always as a predictable cost, especially when you're doing lots and really good insulation and air sealing. So that's all I have. Thank you. Thank you guys for listening to me. Thank you for having me.